Good morning, everyone. We're really glad to have you join us this morning for a special talk. It's outside of the usual schedule of the Research Exchange series, but we're really pleased to have Professor Ben Schneiderman join us this morning. Just a couple of quick announcements before I introduce Professor Schneiderman. I'm Camille Crittenden. I'm Deputy Director of Citrus and also direct the Data and Democracy Initiative here. We're really pleased to have you here in person, and I also want to welcome our remote viewers. We webcast all of these talks live to the other Citrus campuses, which are at UC Davis, Merced, and Santa Cruz, and then they'll also be archived on our YouTube channel, so you can refer your friends or go back for later viewing. We'll have the regular series of the Research Exchange talks resume next Wednesday. The speaker then is Christian Claudel, who will be talking about wireless sensor networks for flash flood and traffic monitoring in urban environments. A couple of other quick announcements of upcoming events. One is Cal Hacks, which is turning out to be a tremendous hackathon hosted here at UC Berkeley. That's going to be October 3rd through the 5th. I think there's something like 6,000 people registered so far. It's going to be held up in Memorial Stadium. It's actually a student group that's organized it, but Citrus and the Invention Lab, the Social Apps Lab, and a number of other organizations on campus are also co-sponsoring. So it will be quite an event. Come and check it out and look it up on the website if you'd like to come. I want to remind you also about the Big Ideas competition. The deadline for that is coming up in November, and there's an information session on October 9th. So you might know that's sponsored by the Blum Center here on campus and has prizes in various categories as well as support for startup projects in various social impact areas, including IT for Society, which is one that Citrus sponsors. Also in the Data and Democracy Initiative, we co-sponsor another one on public open data and on human rights and technology. So with that, I will be happy to introduce our honored guest this morning. Ben Schneiderman is a distinguished university professor in the Department of Computer Science and founding director of the Human-Computer Interaction Laboratory at the University of Maryland, College Park. So you'll hear more from him this morning. He pioneered the highlighted textual link in 1983, and it became part of Hyperties, a precursor to the web. His move into information visualization spawned Spotfire, known for pharmaceutical drug discovery and genomic data analysis. He's a technical advisor for the tree map visualization producer, the Hive Group. So he's working on a new book. We're really delighted to have him here to explore some of his new ideas, which you'll hear about today, on blending science, engineering, and design. Please join me in welcoming Professor Schneiderman.
Thank you. Well, thank you. Thank you. I'm very pleased to be here. As Camille mentioned, I've been working on this new book, and part of it was to talk to Camille early in the summer, and because I'm writing these case studies about different groups that are following or developing similar ideas. I've always admired the Citrus vision, and I thought that was a really good starting point for me, so I wanted to make sure I captured it. The diversity of people is an important issue for me, so I'm curious, how many people are affiliated with computer science or engineering of various kinds, with business, with sociology, psychology, English? What do we got? What else?
Design.
Design. Thank you, Aaron Marcus. What else? What's that?
General science.
General sciences? The iSchool has walked in. What else?
Religious studies.
Religious studies. All right. All right. Well, these diverse disciplines have always entranced me, and my own trajectory was going through several directions as a scientist, as an engineer, as a designer. And here I'm representing the University of Maryland's Human-Computer Interaction Lab, now on its 4th director in its 32nd year. And it's a very interesting, happy collaboration between computer science and info studies with many other groups, including the wonderfully titled Maryland Institute for Technology and the Humanities, MITH. So if you visit our website, there are 750 technical reports, 200 videos, 150 project pages, and a nice video of 5 minutes made recently by the university, and 40 pieces of software you can download. I hope some of you know me from my book, Designing the User Interface. So here is where the bridging begins, because I came from science and physics, and became, computer-oriented, more engineering. And I write this book called Designing the User Interface. And it's all about design. And I became acquainted with the differences of these disciplines, and sometimes the hostility amongst them, and sometimes the lack of awareness across them. And so those were always themes for me, as I had a much more eclectic and interdisciplinary view of the world. This is a good moment to thank Catherine Plaisant, my collaborator for 25 years, who joined me in the 4th and 5th editions to tell the story of the ever-growing world of human-computer interaction, which I had first characterized as a marriage of disciplines in a book in 1980 called Software Psychology, that tried to talk about this notion of bridging disciplines and methods, which I think is the key point. So today, my focus is much more on information visualization. This early book tried to lay out the territory. Others, like Jim Thomas, made a research agenda and broadened the scope to the visual analytics notion. And the Europeans followed suit, led by Daniel Keim. Both these latter two books are free on the web, and if you're interested in the visualization aspects and the way this piece of HCI is emerging, those are good places to go. As Camille mentioned, I'm pleased to have been part of the Spotfire story. In '94, we write a paper, Christopher Olberg and Friends, form a company in '97. And in 10 years grows to 200 people and gets purchased by Tibco. So a very happy story. And this is a genomic data set. This is birth data in Washington, 15,000 babies. The mother's age ranges from 11 to 52. The father's from 13 to 65. The red dots are the girls. The blue dots are the boys. The size of the dots is the birth weight or gestation period, etc. And these multiple windows are coordinated. A single control panel lets you slide and filter all of them at once. So those are the kind of design ideas, engineering ideas, and novel sciences that we built. And Spotfire has many other features. This is the later commercial versions. The tree maps that I had developed became part of Spotfire 6 or 7 years ago. And it's grown to include networks and other kind of technologies. And this is the way you look at large data sets, and that's the way you want to explore. Again, a single control panel. You can sort of see it on the side. 27 windows to represent this rich world of data in a compact and comprehensible way. Of course, there's no secret that visualization has enormous powers to amplify people's ability to discover patterns. Maybe just to say a few words about this is a recent picture of the Bloomberg display. 300,000 people pay $20,000 a year to have that on their desk. And the principles are spatially stable layouts. You don't move and resize windows. The coordination among multiple windows lets you see a lot of data. To me, the design could use some improvements, but it's very much appreciated by the people who are stock traders, analysts of all kinds, who make rapid decisions that are worth millions and billions of dollars. So the visualization notion is growing. I just got on my desktop, here's the way I work, standing up. I encourage that if you haven't tried that. But there's 16 megapixels over here. And I can see 15 pages on a 3x5 display of a paper if I'm reading it. It's a little hard to edit, so I usually work at 8 pages on the display, and then on the right side I can have the emails with people's corrections or suggestions or reviewers' comments, and then a single page down will turn all 8 pages to see the next 8 pages. And this reduced scrolling and reduced visual distraction are extreme facilitators of better cognitive concentration, reduce stress, Pablo, and you are facilitating the exploration of information. And these kind of environments are growing as people understand the high value of having rich information resources readily available, low cognitive load in terms of finding the data, and a simple glance will get them what they need for a lot of the tasks, okay? So, also going small is good. My favorite big data application is this one. College Park's right here. I go 9 miles on the Beltway to my home in Bethesda. And what I'm looking for is the 15 red pixels on the beltway to tell me that it's blocked and I should be taking a different road. So, that's kind of a very simple way. A huge amount of data gets distilled into a small visualization that has high insight and high decision value for me. This is our summer. I grabbed this picture for this talk this summer. Our summer hiking, and I'm proud to show in the middle of August, we walked, Jenny, my wife and I walked 100,000 steps during that week as we were out hiking. And we did 1 million steps over the summer. So you get to understand your own performance, and that kind of feedback rewards you, motivates you, and gets you moving. Here's another tree map on a small phone, but every job in America, that's the volume of government jobs, goods jobs, services, and the leisure and hospitality area is the largest of those. So, and of course, those kind of things. So that's where I come from. The message I'm often known by, this paper in a second-rate conference has almost 3,000 citations by now, a remarkable number, and its message was, show the user an overview first, and then let them zoom in on what they want, filter out what they don't want, and click for details on demand. And each line represented one project where we struggled for weeks or months to come up with a design. And this kind of cute way of describing it and calling it the visualization mantra somehow triggered people's interest. Many people say complimentary things. Some make jokes about it. Some extend it. Some complain about it. Some do different things. But it's become an important theme that I think asserts, the reason I think people like it is it asserts the centrality of the human user. It's not some data mining, statistical machine learning black box that makes the decision for you. You see the overview. You decide what to zoom in on. You decide what to filter out, and then you get to see the details. So I'm always asserting the centrality of the human in work. I live in this territory. Scientific visualization is a long, proud history. My work is more over here. The spot fire generated a rich set of competitors. Tableau is market capitalization of $4 billion or more by now. Stanford friends who did that one, and so they continue. And Tableau is certainly a highly visible application. And that's a great success story, as these others. Event flow is my current effort. We're working on electronic health records. And you may know some of these others. The tree maps, also networks. I hope you'll visit our Node XL tool, free online, free download, 300,000. We just crossed 300,000 users for network analysis for Twitter, Facebook, Flickr, social media analytics, okay? And you may also want to see some of the many, many blogs that eagerly promote, including Stephen Few in the back, Perceptual Edge, one of the more thoughtful, deep ones, and that tells the story, okay? So that was the sort of introduction, and here's the restart of the talk. Here's what I came to talk about. For some of you may not know too much. I wanted to give you an idea where I come from, because this is a very different direction for me. It's a bit of a challenge. I've been reading lots of things I haven't seen before, and maybe some of you will help me. I hope that's my goal here in talking about my struggles in the last year and a half to try to create a new vision of what do we mean by science, engineering, and design. Fundamentally, what do we mean by research, okay? And, what do we mean by high impact? That's kind of a sort of buzzword, and what do we mean? If you look about impact, search the web, you'll find this is the most common image. I was looking for images. That's what people think of when they think of impact. So yeah, we want to make a big impact with our research, right? On the other hand, this seemed to me a rather negative impact, and I looked for other metaphors of impact, and for me, because I think the impacts, the impacts of the last 300 years of science have been the study of the natural world. The impacts of the next 300 years, I think, will be the studies of the made world. Okay, we need to continue the natural world studies, biology, chemistry, physics, but I think the energy, attention, and focus needs to shift to these newer directions. So we still need to learn about biology and genomics and medicine, But the real challenge is health care delivery. How do we, at scale, deliver these services? How do we promote obesity reduction and smoking cessation, stress reduction? Okay? These seem to me the fundamental challenges that take us to the studies of what I call the made world, the built environment, the constructed world. Okay? Those are other phrases. Okay? So what is the metaphor in a positive way? I would say that one is a start. Where's that? London, thank you. Or Shanghai, right. Or New York. I thought, did I get the wrong picture? But a city is a high-impact phenomenon. Stephen Johnson, who's your speaker in a few weeks, talks very eloquently about the way cities concentrate activities and the way that coral reefs concentrate activities, and that trigger creative work in ways that are rather dramatic. And the evidence is, I think, quite well established about it. And Richard Florida's book about the creative class also documents the technology, the talent, and the tolerance that are the indicators of cities that trigger economic growth and creative activities of all kinds. So people are coming to understand that we need to do a little deeper study of these, shall I call them, socio-technical systems, a phrase that's been around for 60 years but hasn't quite swept through. And that the notions of looking more carefully about how to make an impact, how do you create a successful city? Right now, that discussion in my world has shifted to the notion of learning health systems. How do you create a learning health system? A health system that continuously improves and monitors itself and refines its techniques rapidly. Okay? And currently that's quite inhibited because the closedness of the data, the unwillingness of people to share the errors and near misses that physicians make, and the general socio-technical, cultural phenomena that exist in medical systems. I attended 2 NSF workshops about doing research on learning health systems, and I said, wow, that's terrific. You mean NSF would invest in studies about how different alternative models for learning health systems would work? And that's yet to happen, but that may yet be what's happening. And that's a positive indication because of the 8 NSF divisions, social, behavioral, and economic sciences is the smallest and under constant attack by some congressional critics who would like to get rid of it entirely. And yet I see that as the central forms of science and engineering and design for the coming 3 centuries. Okay? I think that's where we're going. So back on the inspiration trail here, the examples I want to promote are, here was a great scientific and engineering and design mission. Thomas Jefferson's wonderful statement for Lewis and Clark was, to find the most direct and practicable water communication across the continent for the purposes of commerce. Applied goal, practical, important. And then he goes on, 2/3 of this letter says you need to study the geography and the geology, the astronomy, the biology, the meteorology, the rivers, and then the tribes and their languages and customs and the ways they raise their families and hunt and fish. And he had this huge science agenda tied to the practical goal. And that to me is a pretty good model of attaining high impact. Okay? Similarly, Kennedy's moonshot speech at Rice University in '61 said, we're going to the moon. Okay, political motivation, applied one, a very visible one, but then he said, we're going to do science along the way. And he actually did say technology and education. He understood that you would carry along all of these notions, that they went hand in hand, that the applied goals and the business and the science went together. Okay? So if you want contemporary inspirations, UN Millennium Development Goals have these 8: eradicate extreme poverty and hunger, achieve universal primary education, promote gender equality, empower women, reduce child mortality, improve maternal health, combat HIV/AIDS, malaria, and other diseases, ensure environmental sustainability, and global partnership for development. And this set out in the year 2000. There's some cases very dramatic improvement, like availability of clean water for many, many billions that didn't have it. So there's some progress, but of course critics see there's not yet fulfillment of the metrics that were set aside for these, and Bill Gates is involved in drafting the next set of the agenda for 2030. So these are the problems we face. And yes, there's some science, but there's also engineering and there's design in these. And I think understanding how to put them together is a very potent one. Aaron, you're...
Where is the design?
Where is the design? I would say each one of these, if you're going to create objects, social structures, those are design. Okay, we'll come back to that. Okay. Another form of grand challenges of the National Academy of Engineering did an effort to list what they collectively considered engineering challenges. There are 14 of these. Again, I think they bridge from engineering to science and also design. And I'll just, the final one is the Longitude Prize. You may know the famous story, the wonderful book by Davis Sobel about in 1714, the British Parliament put out a challenge, 20,000 pounds, about $1 million current dollars. If someone could figure out how to measure the longitude of a ship. They knew the latitude, but the longitude was a problem. And it was a particularly painful one because the British fleet returning from defeating the Spanish Armada, many of them ran aground at the end of England. What's it called? At the very, on the rocks because they just didn't know where they were. And this was a huge battle for 50 years, and the humble country clockmaker, John Harrison, eventually built a chronometer which solved the problem to the great dismay of the astronomers who believed that it would be an astronomical solution based on sighting of the sun, moon, and stars. It's a great drama. They've resurrected that and put out on the web in modern ways a crowdsourced challenge. Which of these 6 should be the new Longitude Prize? And over the summer, the winner is antibiotics, prevent the rise of it. So they're defining it now, and that will be their challenge, and there'll be substantial effort directed towards this topic. All right, so that's this issue of theory of problem selection. And actually, as I searched the literature, including a Google search on theory of problem selection, I did not find anything about advice to scientists, engineers, or designers about how to choose a problem. If you have the freedom, you're not in a company or you're not prescribed what to do, but you can choose a problem. Famous books like Peter Medawaj's Advice to a Young Scientist say that you should choose important problems, not piffly ones. Important, and that's often quoted, although there's not much content there. We all agree important problems are better than piffly ones. But indeed, how do we choose our important problems? How do we know what's important? So that's where I begin as a first question. Okay, and a lot of our choices and a lot of the framing of modern thinking about what is science comes from Vannevar Bush's quite famous, interesting read, still worth reading. 1945, he was FDR's science advisor, famous scientist, developer of analog computers in the 30s, and in many ways a sort of person who pushed the Manhattan Project along. And he wrote this manifesto about how research should proceed now that the war is coming to an end, and advocated a strong support for government funds to universities for basic research. Okay, that was his pitch. And he makes a strong separation between basic research and applied research. Okay? And then writes, statistically, it is certain that important and highly useful discoveries will result from some fraction of the work undertaken. but the results of any one particular investigation cannot be predicted. And he goes on, he warns that applied research invariably drives out pure. And I'm saying this is a dangerous dichotomy that I believe is counterproductive. And in fact, he was wrong. Okay? And the contradiction is even dramatic in the book, because the alternate chapters talk about medicine during World War II and how much the problems of warfare had triggered great advances in medical basic research. Treating of wounds, treating of diseases, tropical climates, so many new challenges, and he keeps celebrating the doctors who stepped up to this challenge and produced, saved many lives and advanced science in dramatic ways. And yet, he goes back and says, give the money to pure research, not to applied, and puts out this sort of warning that applied research is dangerous. Now, I've spoken to Vannevar Bush's biographer, Zachary Pascal, and he agrees that, Vannevar Bush was essentially trying to reward his physicist friends who had left their comfortable homes and went to Los Alamos for 2 years and lived in rather humble circumstances, but they did the job of making the bomb, a remarkable applied result with tremendous payoffs for theory and advancement of science and materials science and so many different ways, okay? So we have yet another instance, although of course a controversial one, but of so many remarkable instances of how when you have an applied clear goal and you work towards that goal, but you also invoke the basic science and publish the basic science, you're going to do better at both. So that's really the thesis of this book, that the old model, so-called linear model, although Vannevar Bush never used this term, in general, his successors cite him for this. He says, we still have this trace in our heads, and many policymakers believe this, that you start with basic research, and then it triggers applied research, and then you go to development and production. And this is very rarely true. Tom Allen's book documents very effectively, and many others, that this just rarely happens. In fact, the NIH is so aware of the painful failure here that they've created $100 million centers on translational medicine to translate the science into practice, which they estimate on average takes 17 years. And to me, it's one of the tragedies and mistakes of our current structure of science policy, which suggests you work science as a basic research independent from application, and somehow later it gets done. But it doesn't. Because the scientists, while being very smart and capable, don't know how to choose the right problems. Okay? So one solution that people have proposed is, well, that one works, there's the struggle, is the so-called reverse linear model. And if industry, government, or others come to the scientists and say, we have a problem, we want your help, they actually can get some help. And because the problem's been chosen well, and the partnership between industry and the researchers is strong, pretty good chance that this is going to pay off. Okay? So this is one theory. And there's some evidence that this can work. Tom Allen's an advocate of this. I'm more pushing this direction, that I want to raise the expectation of what researchers should do. And I would say Citrus is well aligned with this, I hope. I'll look forward to hearing your comments. But that there is an applied research problem, and you invoke a theoretical foundation, and at the same time you advance the theory, you publish the papers, and you solve a real problem. Now, some people say I'm asking a lot, and the theoreticians and the basic researchers would say, don't mess with my curiosity-driven research with your mission-driven problem. Don't make me work on short-term societal problems. I'm thinking of the big solutions that will last for 100 years. But I'm arguing that they're more likely to find the breakthroughs that will last for 100 years if they are driven by clearly motivated problems that have a meaningful application. Okay? Now, you may, if you know the literature, hear the voice of Donald Stokes' famous book, Pasteur's Quadrant. And he advocates this line: use-inspired basic research. And his favorite story is Louis Pasteur, who worked on fermentation of wines and vaccination. And as a result, he developed a germ theory of medicine. Okay, so again, applied problems leading to basic research advances. And I agree with that, but I want to add more. I want more. I want theory-inspired applied research too. And so I'm looking for the places where applied research problems are brought forward, well-defined, and partnerships work with people who know the background, the theory, the models, the mathematics, cognitive theory, social theory, all those different forms of academic work, and then they publish the results in those published scientific journals or engineering or design, and they also solve a real problem, or at least take steps toward that. Okay? So that's the advocacy. All right? And, you know, maybe I can invoke Leonardo here. Theory without practice cannot survive and dies quickly as it lives. And he who loves practice without theory is like a sailor who boards ship without a rudder and compass and never knows where he may cast. Okay, so I'm not the first to say this. Many people have said this, but I think there's a renewed opportunity in the modern world of big data, of web-based and social media analytics, where we have a chance to tackle real problems and communicate more effectively in teams that are formed to address these problems. I've done this in my classes. This is my formula. I tell my students this for their projects, and I always have team projects working with my students. And I say there are 2 parents and 3 children for a good project. And the 2 parents are, you have some theory, that's a basic theory, and you have some real problem with a real user outside the classroom. My students have to have someone. Sometimes I can find one. Sometimes they have one. But they have to work on something for somebody outside the classroom that hopefully endures beyond the semester. Okay, this isn't a classroom. We'll come to research in a while. And the outcome is they refine the theory, they solve the problem, and the third child is they provide guidance for future researchers who take on this problem. Okay, so that's, you know, in the small. You can do this in a 12-week, 15-week semester, and students can actually make something. Not everyone succeeds. Not everyone publishes a paper. My best outcome I'm proud of is one semester of my 30 students. There were 7 teams, and 5 of those teams produced a published paper. It took a little more work after the semester, but that was my best. I used to say 1 in 10 student projects lead to something publishable, but I get to see much more success because I'm finding the ways to get them to work at speed, at scale, on real problems with an outside mentor who cares about what they're doing. Okay, so here we go. Here's my 7-part summary of what I think, this is the structure of the book here, of how we should think about framing science. The first is choosing actionable problems, not just problems, but problems where you actually can act. And that means some connection with civic, business, or global priorities. Okay? And I've given you some of those examples of where they come from. The second is to understand and blend science, engineering, design, research methods. So there's a well-stated scientific method. Okay? Engineering methods are a lot more varied, and design, although Aaron is about to clarify for me how I need to interpret design, but there are design methods, design thinking, strategies that have been proposed that are quite different from the scientific method. And I would say the scientists would benefit, as I have, from learning the design methods and integrating them into their practice. Okay? Just for those, I started as a scientist working on physics, very much inspired by Thomas Kuhn's structure of scientific revolution, thinking that science was the thing. and I became more engaged as an engineer of building computer systems. And I would say then designing the user interface became my theme. And I was, as I did this search on the Google Ngram viewer, it turns out design has gained ascendancy. I didn't know this in 1975. Okay? Design is important. Okay? And I think for scientists to be aware of these larger trends is going to open their minds and say, hey, maybe there is something important. And the growing importance of design, I would say, is manifest in this figure. All right. The third part of this building the house of high-impact research is to form teams, okay, with diverse individuals and organizations. Now, that's carefully worded. I used to say interdisciplinary, and I've backed off from that. That's a whole other discussion. But having teams of even 2 people turns out to be very much more effective. And actually, the KDD conference, Knowledge Discovery and Data Mining in New York, had really interesting 2 lovely data points for me that will wind up in the book. They had 1,000 papers submitted. They chose 140 of these for publication, in the conference. It's a pretty tight, competitive view. Each paper got 3, 4, or 5 reviews, which had critiques and also had a rating. And it turns out that the papers that had 2 authors and 3 authors and 4 authors and 5 authors got successively higher ratings. After 5, it leveled off. So there's something about working with other people that brings you other ideas, maybe more abilities, a different perspective. But even the very simple process of my having to explain to you what I'm doing of 2 people turns out to be a very powerful story. And there's a new book out called The End of the Lonely Genius, or The End of the Lone Genius, I think it is. Joshua Schenk's book. I just, I'd read the reviews and just downloaded it to get into it. But this actually repeats other historical evidence that even the great lone thinkers, actually they had people they talked to. And in the past, the literature points out there are 2 kinds of people they talked to. One was a colleague who was knowledgeable about their work, and they could explain what they were doing to and get the technical, feedback. The other was a more social support, often a spouse or a friend, and they would say, Alfred, don't be discouraged. You've had hard times before. You'll get through it. Keep at it. Stay with it. And that kind of encouragement is another form of partnership or team that you want. And mentors often play the role of encouraging younger students, inspiring them to get to work. The diversity, the second data point from this conference data collection, I love this one. The papers, which were authored by all academic authors, and the papers that were authored by all industry authors, had statistically significantly lower quality ratings than the papers that had authors from industry and university. Really sweet result that I haven't seen anywhere else, but I think that's the indicator of the story I'm telling here, that by having this kind of diversity. Another good work, Brian Uzi at Northwestern, talks about atypical references. The high citation papers in the Web of Science, the high citation papers, have an injection of something that's outside the discipline. That analysis celebrates the importance of disciplinary strength and references to a discipline over a period of years, and the injection of an atypical reference that comes from a different place. Those are the triggers of the top 1% cited papers. So we're beginning to have the data as a variety of analysts have been studying the bibliometrics and scientometrics of this field. Okay? I guess here's the slide just to mention. Teams are usually effective. They are difficult to run and form. May take practice to gain skills, so beware. Teams more often fail, but when they succeed, they actually see succeed quite famously. The question? Yeah?
I have a subtle question about this. I heard a talk from Cacioppo, this emotional researcher, and he says emotion is a very hard problem. It has to be studied from multiple angles.
Who's the researcher?
Tom Cacioppo.
Don't know. Okay, go ahead.
He's a neuroscientist.
All right.
He said the problem is that authoring right now in papers is like not like physics. It's like you want the first author to become more relevant, and then forming a team around the paper becomes difficult because authoring precludes it, because you want the leader who's going to be up front, and then the rest. And then you don't have the physics approach, which is just alphabetical ordering, and everybody has the same weight. And I think that's a problem.
So different fields, in fact, different countries have different kind of cultural phenomena. In Europe, alphabetical ordering is more common. In biology and physics, the first author is the prime one. The last author is usually the head of the lab. And then there's some jockeying for being second or second to last. And these things have to be negotiated. The main reason teams fall apart, there's two main reasons. One is because one of the people moved to another city, and telecommunications doesn't do it. Face-to-face is very important for teams. Okay? The second reason is conflicts over authorship and ownership of ideas. Okay? So those are, you're absolutely right. And I hope I've said it clearly, they're difficult to run, difficult to form. And I've run into these problems too. Marty?
Probably you're right about what you're saying about the teams. I will just make a little note about 80 in particular. You might want to compare it to other conferences before you conclude, in that conference very much rewards big data. It's a big data conference, and it could be that industry has the big data and academics doesn't in this case.
Right.
You have to have the industry person on your team to publish successfully there. If you're an academic, the industry teams alone maybe won't have as good a paper as a team an industry that includes an academic, potentially.
Well, what do the academics bring then? What's your argument?
The academics might bring a better analysis.
Okay. Well, that's fine. I don't think that, I think you're supporting, I think that comment is supportive of the bridging, that if industry people have the data and they know the problems. When I get approached by industry people and they say, I want to visualize my data, I say, okay, we're very pleased. And I say, there's 4 things I need. Do you have the data? Can we get to it? Okay. Are you going to work with me? Okay. Do we have a schedule to do this in the next 6 to 8 weeks or something like that? And do you have some questions to get started? If you don't have questions, you're not ready. And so I'm looking for that kind of, I have a systematic way of working with industry partners that I want to have a few things in place to make sure it succeeds. Of course, even then, there's still challenge and it doesn't always work out. And each one of these is, maybe you can certainly find some flaws, but let's see. I'm going to try to lay out a little more and then we can come back, but I value your challenges. For larger teams, I mean, the science of team science is the place to go. The 5th conference was just held in Austin in August. Very interesting collection of researchers studying the science of team science. And there's other things. The cancer.gov has a thing called Team Science Toolkit, which are resources to help people form teams and research about teams, etc. And of course, teams can be 2 people, 5 people. As Citrus requires 2 universities, a very interesting requirement that does ensure some other kinds of collaboration, but adds challenges. As Kiesler and Jonathan Cummings have shown, collaborations across institutions is much more difficult than collaborations at the same one. So you're admirably taking on that challenge, and there are good reasons for you to do that, I think. But these, raise the barriers, and I think we have to understand what the barriers may be. There are larger teams of hundreds or more, sometimes at an NSF Science and Technology Center, sometimes at an NIH regional center, or they have 23 institutes of the NIH. And so people are trying to arrange for these larger groups to work together. The collaboratory term, now a term faded out, but Gary Olson, Nathan Boss studied 213 such collaborations and made a taxonomy of 6 different kinds of them that I think makes for interesting reading. in their work. So there's a lot more to be said about this, but it's one thing to think about, how to structure a team. Young and old, gender differences, topic differences. Is it better for an algorithmic computer scientist to collaborate with a systems person, or a computer scientist to work with a dance, professor? I mean, is a greater range of interdisciplinarity a better thing? Is it going to produce higher impact results? Those are pretty tough issues to work on, but I think people need to be aware about how far they're bridging and how wide a net they cast in terms of this. So there may be too much interdisciplinarity in some cases. There's a risk going there. All right, let me go on. Number 4, that I want to keep people thinking about universal theories, general principles, and guidelines as outcomes. I mean, that's what we think of science predictive models as 4 kinds of explanatory, descriptive, predictive, and prescriptive are what my estimate of different kinds of theories and the results of research that we want to get to. I will itemize those right here. Okay, I think there are 5 kinds of theories, and descriptive theories going back to Aristotle, taxonomies that say, well, there are vertebrates and invertebrates. That's a description of what he saw. Okay, and those things are very helpful in organizing a discipline and telling a story. Explanatory, that says, well, if you put a fire under, some wood, it'll burn, and kind of cause-effect stories, or those are important as well, that explain things. Predictive, usually numeric, is tougher. We want to be able to predict when the next eclipse is, or how much acid will emerge if I put some calcium carbonate in some, in some bath or fluid. Prescriptive means guidelines, prescriptions, best practices, pattern languages. Christopher Alexander's, pattern language, fit those kind of things. And I think we have to give them more credit. The predictive models win in our mood of statistical machine learning and data mining that you want to be numeric, quantitative, and predictive. Yet prescriptive, I think, have important powers. And they are maybe sometimes early stages when we haven't formalized an area, but sometimes they are wise prescriptions, such Christopher Alexander's formula. There are potent little lines of light from 2 sides. The design of a room should have, to make it aesthetic and pleasant, is to have light coming in, natural light from 2 sides for a room. That's a nice idea. Can I prove that it produces better houses, better lifestyles, lower stress? I don't know. But it's kind of a good prescription to remember. Sometimes the prescriptions are a little more embedded in codes. I understand for public buildings, you need 2 exits within 150 feet of every point in the building. Okay, so if there's a fire on one side, you can get out somewhere else. Why 2? Why not 3? Why not 300 feet or 200 feet or 100 feet? Well, we have to, come to that. Okay, and other kinds of theories are out there. I'll move forward with my 2 more. The prototypes, building real things. This is the Google hybrid model. One of my case studies is Al Spector's description of how Google does work. You get in there, you build real things, you ship the code, and you try it out with real people in situ at scale, not in a laboratory in a constrained way. Camille's looking at me to say, get going. All right. Big data and case studies. The blending of large statistical, quantitative, as well as qualitative data. The certification and the improved rigor of case study methods, which is what we've come to use in our evaluations. A Ph.D. student who recently finished with me did 13 case studies of his data visualization for hierarchical data over time, working with the government's Office of Management and Budget, with the FDA, with the FAA, with all kinds of Washington groups. Each case study built our confidence. We learned things about it. Okay, so I guess the prototype and test, something small soon is what I tell my students. Build something small soon, 2 days, 2 weeks at most, and then we'll refine it. This is often called Agile Development, and I think these things may be known to you. There's a lot of other prescriptions like writing early, writing your research narrative when you start. Just read a great paper that appeared on Monday about which research science papers get disseminated most by the general public. It turns out women take notice. Papers written by women more often do. Is it because of their choice of topics or because of their writing style? And the important thing is it be useful, that it be relevant, that it be informative, non-technical. Very sweet, evidence from 800 papers and their dissemination and their impact on people. All right. So I believe in writing from the beginning. I think we have a tradition that says, first you do your research and then you write your Ph.D. Wrong. I think you start writing from day one. You write your abstract. We do require proposals to be written and defended, and doing that kind of thing is really important. Okay. Finally, the days of publish or perish are gone. It's publish and promote. You can no longer be an isolated scientist publishing brilliant ideas. You need to be promoted or have someone do it for you. Okay? Telling the story and getting out there. And maybe the best description at Washington University, St. Louis, the medical librarians have a great page with 46 ways you should be promoting your research. It's actually pretty sweet, a lot of social things, but they have a couple of things in their central belief, reinforced by others, that ideas travel through networks and relationships. You have to write the paper, but you also need to get out there like I'm doing and talk to people, right? And make the connection and build your network. And the evidence is growing for that. And so they have a cute way of phrasing it, cultivate champions for your work, but they say present, 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 which I think is a pretty interesting one. What else? I think they've got, there's 46 of them. You can take a look at that. I'm getting close. Then, you promote adoption. I've got this rule for my students called, jokingly, send 5 and thrive. You've written a paper, and you're about to submit it for publication, and you write, I tell my students, find the 5 people in your citation list that you think are most relevant. Get their email addresses and send them an email that says, Dear so-and-so, I'm a graduate student at the University of Maryland working with Ben Schneider. He sends his regards, okay? The attached paper references your work. Please tell us, 1, if we've been fair to you in citing your work. 2, have you done any more recent work in this area? My students are stunned and shocked that within 24 hours, they tend to get all 5 responses from leading researchers around the world. Because I respond to that kind of a note, too. It engages, it makes my students makes them networked in, makes them a prominent person, and they connect with the real leaders who then provide the feedback and get them. It also influences the way you write your paper. I find students and assistant professors tend to write, the work of so-and-so failed to do X, Y, Z. My work remedies this failure. You know what that student's future is going to be like, all right? As opposed to the pioneering work of so-and-so can be extended by X, Y, Z. I mean, how different? I mean, it's the same story. It's just the tone. And if you write with the idea that it's going to be read by the people you're writing about, you will change your tone. Okay? Measure impact. This is a whole separate talk. Maybe after lunch I'll come back and do the other part of the talk. But measuring impact's a really tough thing. The old way of citation counts are losing prominence. They're nice because they are objective, but citation counts take 3 to 5 years to accumulate. They're very biased, and they favor only the scientific community. Whereas the download counts are more effective. So I wrote a paper with Jeff here. I hope some of you know. Jeff got his degree here and went to Stanford. We wrote a paper together that was published in the Communication of the ACM, and the full version in the open, free ACMQ website. On the printed journal, or magazine, some would say, it had about 4,000 downloads. Of course, there were 100,000 paper copies shipped. Okay. On the website, there were 134,000 downloads of this paper. Startling to me. Startling. And the accessibility of new ideas on the web. I guess, Stephen, do you have download counts for your site? I
never pay attention.
Never pay attention. Okay. I think you might be interested to see which things do generate more attention and which things don't, and what aspects of it, make a difference. So there's been a growing recognition and research on these topics. I could talk more about these. I did mention the Science of Team Science Conference, now in its 5th year, started 2010. NSF is devoting energy and resources to this. There's other professional groups. And then the Altmetrics Conference, now in its 3rd or 4th year, is looking for alternate metrics to assess impact of science that balances the academic with the industrial side of things. The Becker model for promoting your work, also for assessing, goes against the idea of citation counts, has a 16-page list of all the ways you might impact the world, and has 5 categories. A meaningful, thoughtful document. Still, I must say my leanings would be I think you need to balance the objective measures with the subjective measures. So I'm a little unhappy with the Becker model, which favors that people read and examine the portfolio of work of a person being hired or promoted. The danger with that is the bias of senior faculty who may have more weight and strength. And so, as the joke goes, disciplines change one funeral at a time is painfully true, and getting new ideas embedded in a discipline turns out to be a lot harder than you would think. I think I'm there at the end. I'll just say, come visit us at HCIL online, or follow me on Twitter at BenBenDC. And I'm sorry for going long, Camille, but I hope your interest. I know some of you may have to leave, but I'm glad to follow with questions, and I'll give Aaron, a dear colleague and buddy for many years, the right of first.
That's sweet, Ben. As you know.
Thank you. I'm sorry. I'm just going to give you the microphone because this
Thank you.
Professor Schneiderman.
Thank you.
So I see some of you are taking photos of the slides. Also be reminded that it will be available on the website, so you can go back and review then.
Thank you, Ben. As you know, I studied physics and then reached escape velocity and went to design school. And I've lived in the design world for 40 years or so. It's very exciting and tremendously moving to see you try to bring these disciplines or fields of knowledge.
I call them disciplines, right?
Together.
But
to follow your example earlier, I think it would be helped with some further attention to the design disciplines and design theory, and to bring that into this research-oriented discussion. And I quite understand with this audience and this university group that it would be as so oriented as it is now. But it's fascinating that one of your slides that was a description of your class project was labeled, I'm sorry, I can't remember, I don't know which number it was. Right in the center it said research project. There, there it is. So you could have called that a design project. And in some design schools, you would have a very similar diagram. So by talking with the design community more, you might get some further input, some additional concepts and a taxonomy and research resources,
Yeah.
et cetera, that would actually bring this discussion to be more powerful. And the fact is, it is already going on in the world and has progressed tremendously in the past 30
I
years.
should say I've sent Aaron the first 2 chapters, which lay out the larger vision. I will send you the chapter on design and design theory.
I would love to see that.
And then you can critique that. But Aaron pointed out, of course, the Bauhaus School had its design, and Venturi and others.
But not only that, we're trying to bring technology and business and design together
Correct.
to improve society in
Yes.
various ways. One other thing that I did mention to you also is the need for a reference to ethics
Yes,
underlying
that was-
this, that
right.
all of this activity is supposed to be for the social good, the public
Yes.
good, blah, blah, blah. And there is very little ethical education in the work of ourselves as professionals, as scientists, et cetera. My wife's thesis, Leslie Becker, Design and Ethics, is available at Amazon and is one of the few documents that try to
Yes.
bring it together in a way that could be applied within this realm.
I fully support that. I will add that to these opening chapters. My references to that go under the idea of human responsibility for the work under the research. So, in architecture, historically, if the building fell, the architect was punished. There was responsibility, okay? And I think the ethics emerge from, to me, they're tied with responsibility and clarity. But I think you may say they're separable issues. Robert, let me...
I was wondering if you know of anyone doing research on visualizing patterns in geopolitical history.
Geopolitical history. Well, recorded future might be an interesting place to start. But yes, there are. I can't remember her name. Actually, Merced in the history department. What's the name? Woman, Helen, help me. She's a geographer, but she's trying to do visualization of geopolitical histories. There's a tool called GeoTime, which makes time a 3-dimensional aspect. There have been various efforts.
What was her name again?
I don't remember
Merced, you said?
at Merced. I can dig it out for you.
Okay.
Yeah.
Good.
Yeah.
Question, fascinating
Costas,
talk.
thank you.
The,
Director of Citrus.
Thanks. Academics are, for the most part, rational beings, and we tend to respond to the way that we're being evaluated and promoted and advancing and so on. And in our work with Asia, we saw dramatically different systems in evaluating. For example, Asian universities, the ones that are moving very high in the ranks now, they use fairly quantitative measures, which, of course, at Berkeley we try to avoid, like the plague. We depend on peer reviews and that talk about quantity, that talk about quality, and so on. None of these systems rewards impact, because impact has a time constant that is incompatible with our advancement.
Yes.
So what can you comment on that?
Yeah. I think there are a lot of open problems and research issues here. I would say, the question is about how can you assess the impact of a young researcher's work, for example, if you're promoting or hiring.
I would say, how would you modify the academic evaluation system
in
order to move us into a model like this?
Right. I mean, I am trying to get there with some recommendations. There are some places that have innovative ideas. Duke University would be one example to point to you. But I think the shift, for example, one that's happened in computer science, Dave Patterson wrote about this, is the shift to focus on conference papers rather than journal papers. Journal papers tend to take longer to review, longer to publish, and then the impact is seen much later. Conference papers tend to be a shorter time frame. You get a review, paper's published, it's on the web, in computer science anyway, and then you have the download counts, and the increasing approach is study the traffic patterns in blogs, social media, Twitter, and so on. If they're being discussed and cited and retweeted, that's an indication in the short term that you've produced some kind of impact and registered with people. The industry applications are others, patents. Becker's list has 16 pages of these things. So there's an exploration. I'm not yet satisfied. We haven't yet settled on it. But I think there's a worthwhile effort to try to find short-term impact measures. NSF gets huge pressure from Congress to say, why should, please prove that the $7 billion we give you has a good payoff, okay? And NSF has developed the so-called STAR metrics. You're probably familiar. This is Julia Lane's model. But it's based on shorter-term feedback that measures the size and density of the network that you construct as a researcher. And the data is available. The universities that NSF gives awards to are required to track the money you spend, the trips you take, the papers you publish, the students you graduate, and the talks you give. And that is a way that they believe they can extract more reliable metrics. The NIH has, for 10 years, and NSF, tried to see if the early counts of citations for a paper would predict the future, and they can't. Okay? So we know citation counts are problematic, and there's a great opportunity now, as people have shifted away from subscribed journals to reading online based on social media recommendations. The evidence is from 1977 to now that there's about a doubling. Scientists they used to read about 150 papers a year, they now read 300, and they read much more diversely. They used to read from a small number of journals that they subscribe to, now they read quite promiscuously, we'll say, in very many different areas, which may be a good thing, it may be a burden. But so I've written half of that chapter. Maybe I'll send that to you when I get a little further. I saw a hand. Julie?
So we have time for just one more question, and then I'm sure Professor Stony would be happy to stay.
Sure. There were just 2 points that you made that I found particularly personally powerful, other than everything else being particularly interesting. One of which, the acknowledgement that moving into industry and business with your academic background can still be quite powerful. You can, affect change and do meaningful research on applied problems that, will end up hopefully back in literature and spreading ideas. That was sort of something that I did after academia. I said, I don't want to be in academia anymore. I want to go off into the private sector and work in business and consulting and, apply my knowledge there. And I was warned, oh, don't do that. You'll never be able to come back. And I don't think that's really true. Maybe that
I think those who come back have maintained their academic publishing profiles.
Sure.
So you need to be in corporations that are sympathetic and supportive of your publishing, which there's a mixed story about companies that do that. So you have to find that, as well as colleagues who will support that notion. So yes, that's an important issue.
Yeah.
You might be interested, I think you especially, the blog post by Lada Adamic, a professor at Michigan, who left the School of Information. She was fed up with the academic work style, which particularly emphasized individuals, and left her feeling it was always competitive. No matter what, the ratings and the performance were for individuals, not teams. And she went to Facebook and found that there, in most companies that, especially engineering-oriented, that are building a product, there's a team commitment. And there's a sense of participation in building something together. And the well-managed companies also give individual researchers focused topics and projects by which they can publish on those as well. So you want to find your way to get your individual prominence, your team partnership, and for her being embedded in a larger social structure that was not competitive but collaborative, where there was a team spirit of great. I know that in my university, and I'm sure yours too, no matter what you do, if one person's success, everybody looks around and they may thank and compliment them and say good for the team, but there's basically a competitive atmosphere which undermines the aspirations of the organization. So I think in Citrus you're probably aware about this, but how do you create a sense of commitment to a community and benefits for all? Thank you for staying. I am glad to stay longer. I do appreciate it. It's the first time I've spoken about this, and so this was sort of a challenge for me to go in a new direction, and appreciate your attentiveness and your challenges. Thank you.